Welcome. In this video, I am going to explain about power and energy. Power is the rate of doing work. That is, power is equals to W by T. It is the measurement of power. Power spent by a source depends on two factors. First one on work done by the source and second one on the time taken. As the time taken will be less, then the power will be more and vice versa. As we have studied in the previous video that work is equals to force dot displacement. So we can write here power is equals to force dot displacement by time. We already know rate of change of displacement is velocity. So we can write power is equals to force dot average velocity, and we can also say that power is the dot product of force and velocity vector. As it is the dot product, therefore power is a scalar quantity. Now we will learn about the units of power. So let us see the units of power. Units of power. In this, first we will see the SI unit. SI unit of power. As we know that power is equals to work by time. Work SI unit is joule and time SI unit is second. So we can write joule per second is the SI unit of work. SI unit of power. Joule per second, or we can say it as a watt. Capital W. We can define 1 watt. What is 1 watt power? What is 1 watt power? To understand the definition of 1 watt, we can take this formula or the measurement of power. Power is equals to work by time. So power is 1 watt if work done is 1 joule and that work is done in 1 second. So we can say that power spent is said to be 1 watt if a source completes the work of 1 joule in 1 second. So this is the SI unit of power. Now we can talk about some bigger units of power. So bigger units of power. Bigger units of power we can talk like, first one is as we understood the SI unit is watt, so we can write kilowatt. Kilo means 10 to the power 3 watt is called 1 kilowatt. Second we can talk that is megawatt, or 1 megawatt is equals to 10 to the power 6 watt. Next we can talk about 1 gigawatt, that is 10 to the power 9 watt. So these are the bigger units of power. We can also write some smaller units. We must know some smaller units also. Smaller units of power. Now in this, like we used kilo, so we can use here milli, micro, like that term. So we can write that milliwatt. 1 milliwatt is equals to 10 to the power minus 3 watt. 1 microwatt is equals to 10 to the power minus 6 watt. So these are the smaller units of power. We can talk about the CGS unit of power. So what is the CGS unit of power? As we have just seen this one, so CGS unit we can write like that also. CGS unit of work is erg and time is second. So erg per second is the CGS unit of power. So this is the SI and CGS unit of power. In mechanical engineering, we are measuring the power in other unit, that is the practical unit. Like the power of a motor is measured in HP, horsepower. So what is 1 HP? Practical unit. 1 HP horsepower is equals to 746 watt. So 746 watt is called 1 HP, 1 horsepower. Now this is all about power. We will understand about energy. So what is energy? Energy and work are very closely related. We can do work if we have energy, and we can perform only that much work what amount of energy we have. So we are telling energy is the capacity to do work. Now we will see units of energy. Units of energy. In this first SI unit, as I said, it is just related to work, same like work. So we can write the SI unit of energy is joule, capital J. Similarly, we can talk about CGS unit. So CGS unit is erg, just like work. We can also talk other units of energy, that is the bigger unit. So let us see some bigger unit of energy, that is, I am talking about the bigger units. Bigger units. In this, first we will talk about watt hour. So what is watt hour and how we can understand what is the value of 1 watt hour? Let us learn this. As we already know, power is equals to work by time. So we can write work is equals to power into time. As I said, work is equivalent to power. Work is equivalent to energy. So this is energy. So energy is the product of power spent into time taken. So we can write 1 watt hour, that is 1 watt hour is equals to power 1 watt, that is done in 1 hour. So what is 1 watt hour? 1 watt hour, we can define 1 watt hour. 1 watt hour is the energy spent. 1 watt hour is the energy spent by a source of power 1 watt, of power 1 watt in 1 hour. 1 watt hour is the energy spent by a source of power 1 watt in 1 hour. Now we will find a relation between watt hour and joule, that is the SI unit of energy. So let us find this. As we have just learned, 1 watt hour equals to 1 watt. 1 watt we can write as 1 watt into this time, take it in SI system, so we can write in 60 into 60 second. So it will become 3600 joule. So 1 watt hour is equals to 3600 joule, or 1 watt hour is equals to 3.6 kilojoule. So this is the relation between watt hour and joule or kilojoule. Let us see the other unit. Similarly, we can talk about other unit. The second one we are talking, that is kilowatt hour. So what is kilowatt hour? As we have just seen there, the power of source was power spent was 1 watt. Now if power spent will be 1 kilowatt, then it will becomes the kilowatt hour. So let us see this. 1 kilowatt hour. 1 kilowatt hour. The energy spent by a source is said to be 1 kilowatt hour if the source spent a power of 1 kilowatt in 1 hour. Similarly, we can just write 1 kilowatt hour is equals to 1000 watt into 60 into 60 seconds. So it will become now 3.6 into 10 to the power 6 joule. So 1 kilowatt hour is equals to 3.6 into 10 to the power 6 joule. 1 kilowatt hour is the energy spent by a source of power 1 kilowatt in 1 hour. So this is the kilowatt hour. Now we will talk the other unit, that is calorie. So what is 1 calorie? Let us see the other unit, that is calorie. Calorie. 1 calorie. How much energy is said to be 1 calorie? 1 calorie is the amount of heat energy required to raise the temperature of 1 gram of water through 14.5 degrees Celsius to 15.5 degrees Celsius. So 1 calorie is the amount of heat energy required to raise the temperature of 1 gram of pure water through 14.5 degrees Celsius to 15.5 degrees Celsius. This calorie is also related to joule. 1 calorie is equals to 4.186 joule, or we can write 1 calorie is equals to 4.2 joule. Other relation also we can write as 1 joule is equals to 0.24 calorie. So this is the unit calorie. We can also talk one more unit for energy, that is electron volt. So what is electron volt? Let us see. Electron volt, EV. To understand this, first we will know that as electric potential is equals to work done per unit charge. This work is again Q into V. So we can define, as I said, that work is equivalent to energy. So we can define electric volt, or 1 electron volt is equals to, what is 1 electron volt? 1 electron volt is the energy, or 1 electron volt, the energy gained by an electron. The kinetic energy gained by an electron when a electron is accelerated, we can say like that, 1 electron volt is the energy, that is when an electron is accelerated through a potential difference of 1 volt. If a potential difference of 1 volt is applied and the acceleration produced in the electron is called the 1 electron volt energy. Like we can write charge, that is charge on an electron, and into we can write that volt, that is 1 volt. So 1 electron volt is equals to 1.6 into 10 to the inverse 19 coulomb into 1 volt. So we can write 1 electron volt is equals to 1.6 into 10 to the inverse 19 joule. So this is the relation between electron volt and SI unit of energy, that is joule. Now in next video I will explain about the mechanical energy, that is the form of energy like kinetic energy, potential energy, and work energy theorem. Okay, so thank you students, thank you so much.